Good morning to all. Today, in connection with the previous class, you have to learn some more things. I have given some solutions to some important questions in my notes that also you have to watch and understand. About them I explained. Now also I will explain in connection with them. Listen carefully. A convex hexagon. It is important thing. A convex hexagon. No internal angles can be more than 180 degrees. I have shown in my book, after my talking, after my lecture, you can go through it and listen now and go through it. A convex hexagon, everybody must know it. No internal angles can be more than 180 degrees. Is there concave hexagon? Yes. Similarly, or differently we can say, when any internal angle is greater than 180 degrees, it is a concave hexagon. Again I am telling, no internal angle can be more than 180 degrees. No internal angle can be more than 180 degrees is convex hexagon. Like this, 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 like this. You know that one, that figure. Like this, like this, like this. So enclosure. 6 sides, hexagon 6 sides, 6 vertices or 6 vertices, 6 meeting points, 6 vertices, 6 sides, it will contain. Convex hexagon means what? No internal angle can be more than 180 degrees. Concave hexagon is any internal angle is greater than 180 degrees. That you should know. And next, number of diagonals of convex hexagon. Convex hexagon, number of diagonals. Here 6 edges or 6 vertices are there now. Every 2 vertices, if you join every 2 vertices, you will get one diagonal. So 6C2, you will get diagonals and the sides. Again I am telling, 6 vertices are there. 2 vertices if you take, this is 2 vertices. 2 vertices if you join, you will get one side. This vertex and opposite to the vertex if you join, you will get one diagonal. So 6C2 gives us the joinings of 2 vertices or 2 points, in which sides are also there. How many sides are there? 6 sides are there. So 6C2 minus 6. 6C2 minus 6. The diagonals, number of diagonals are 6C2 minus 6. 6C2 means 6 vertices are there. Every 2 vertices if you join, you will get one side or diagonal. Therefore, 62 will give us diagonals including sides And now we are going to subtract 6 sides. 6C2 minus 6 equals to 9 diagonals. How many diagonals will be there? 9 diagonals. How we will get 6C2 minus 6 equals to 9 diagonals we will get. These are the number of diagonals, 9 diagonals, 6C2 minus 6, 9 diagonals of convex hexagon. This is very important. And this question also described and explained in this video. Please go through it. Next, come to another point is playing cards. Playing cards. Everybody knows playing cards. They used to play. With regard to probability, how the playing cards will play important role. Because the questions will be given on playing cards also. With regard to probability, we have to learn some points. Here, 52 cards are there. Everybody knows. 52 out of 52 cards, out of 52 cards, all cards are divided into 4 suits. This thing also will be, I have given in this video on the paper. After my lecture, you can go through it. And now listen also. Well shuffled deck of 52 cards. They will say like that. Those terminology they use. Well shuffled deck of 52 cards. All cards are divided into 4 suits. 4 suits. S-U-I-T-S. 4 suits. There are 2 black suits. 2 black suits, spades and clubs, and 2 red suits, hearts and diamonds. Again I am telling, the well shuffled deck of 52 cards divided into 4 suits. S-U-I-T-S, not S-H-O-O-T. 4 suits. There are 2 black suits, 2 red suits, 2 black suits, spades and clubs, 2 red suits, hearts and diamonds. Hearts and diamonds. In each suit, 13 cards are there. In each suit, 13 cards are there. Those 13 cards is, first A, yes, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King. So I have told you, in place of 1 I have told you yes, S-E, yes. Capital A. Numbers from 2 starts. 2, 3, 4, 5, 6, 7, 8, 9, 10. Afterwards, Jack, Queen, King. J, Q, K. Total 13 cards. Total 13 cards. Here, out of 52 cards, 13, this 13. So 4 into 13, 52. So how many suits are there? 4 suits. Every suit, 13 cards. I told you 2 black suits and 2 red suits. I told. Black suits are spades and clubs, and red suits are hearts and diamonds. Out of 52 cards, 12 of these are face cards. 12 of these are face cards. What are the face cards? J, Q, K. Jocks, Jock, Queen, King. All Jock, Queen, King. These three are face cards. How many suits are there? 4 suits. 4 suits are there. 4 into 3 face cards. How many face cards are there? 12 face cards. 12 face cards. So, what is the face card probability? 12 by 52. 12 by 52 is nothing but, I think, 23%. 23%. It is 23%. 12 by 52 probability. Face card probability. Face cards are Jock, Queen, King. Aces are always higher than kings, but often lower than jokers. Aces are always higher than kings, but often lower than jokers. This is you have to learn. And in a convex hexagon, one question I have given. It is very popular question. Everybody must learn it. In a convex hexagon, 2 diagonals are drawn at random. The probability that the diagonals intersect at an interior point of the hexagon is 5 by 12. The probability that the diagonals intersect at an interior point of the hexagon is 5 by 12. N of S, sample space, 9C2. Why 9C2? Because 2 diagonals drawn at random. 9 diagonals are there. Selection is 9C2. It is N of S. And what is N of E? Diagonals intersect at an interior point. So I want to take 2 diagonals, means 4 vertices I will take. Because 2 vertices form one diagonal, 2 vertices form another diagonal. So out of 6, out of 6 vertices, out of 6 points, out of 6 vertices, I want to take 4. I want to select 4. 4 implies, what is it? 2, 2. 2 is one diagonal, I think. Another 2 is another diagonal. Such a way they are intersecting at an interior point of the hexagon. Therefore, N of E is 6C4. Out of 6 vertices, I am selecting 4 vertices, as I am taking 2 for each diagonal. So 2 diagonals I suppose to be intersecting interior of the hexagon. 6C4. N of S is 9C2. 9C2 is 36. 9C2 is 36. 6C4 is 15. So P of E, probability of the event is 15 by 36, 5 by 12. The same question on paper I explained. Please go through it. Here, I want to tell you another thing. You are learning some logical operations in combinatorics. Really, I'm telling. Because when you see here 9 diagonals in convex hexagon, 2 diagonals we are taking at random. So 9 C2 selection. 6 vertices will be there, and the join of 2 will give us one diagonal. Supposed to be 2 diagonals, 4 vertices. Out of 6 vertices, I have selected 4 vertices, supposing that they are intersecting interior of the hexagon, convex hexagon. So some logics are there. Some logics. Here I want to tell you another point, and I'm going to end this today by telling this. You see here, in permutations and combinations, in the arrangements, groups will be there. Simply I will tell, in one basket, 10 mangoes, okay, 15 oranges, and 5 apples are there in one basket. Okay, total how many fruits are there? 10, 15, 25, 5, 30 fruits are there. These 30 fruits you have to permute. You have to permute. In how many ways? For this, simply 10, 15, 5. How much? 30 factorial by 10 factorial, 15 factorial, 5 factorial. Again I am telling, as a group or as groups you have to keep in denominator. Again I am telling, in one basket 10 mangoes, 15 oranges, 5 apples are there. You have to permute them in how many ways? Total fruits 30 factorial by, as groups you have to tell 10 factorial, because mangoes. Together 10 factorial, and 15 oranges, together 15 factorial, and 5 factorial, 5 apples. You have to keep in downwards in denominator. So we can permute the fruits in the basket containing 10 mangoes, 15 oranges, and 5 apples as 30 factorial by 30 factorial whole by 10 factorial, 15 factorial, 5 factorial. This, the same thing you will again also learn in combinatorics and permutations. I will tell you. Later I will tell you. But now I think you have understood when groups are given. I have given one fruit basket example, and this will make you understand better. In the same manner, one question will be given here. A 5 rupee coins, 4 5 rupee coins, 3 2 rupee coins, and 2 1 rupee coins. Again I am telling, 5 rupee coins, how many? 4. And 2 rupee coins, how many? 3. 1 rupee coins, how many? 2. Okay. So how much? 4, 3, how much? 7 and 2, 9. Okay, 9 factorial by 4 factorial, 3 factorial, 2 factorial, that is n of s, sample space. What is the question here? 4 5 rupee coins, 3 2 rupee coins, and 2 1 rupee coins are stacked together in a column at random. Means, what is n of s? Total how many? 9 factorial. What is that? 4, 3, 2. 9 factorial by 4 factorial, 3 factorial into 2 factorial. That is n of s. Next, what is n of e? N of e, how do we find? Let us read the question. The probability that the coins of the same denomination are consecutive. The probability that same denomination are consecutive. Same denomination. Same denomination means here 5 rupee coins, 2 rupee coins, and 1 rupee coins should be in the same denomination. Means 3, 3, 3 denomination. Then it will be 9, no. Same denomination. Same denomination means you have to take 3 as 1 unit, 3 as 1 unit, 3 as 1 unit, but the coins are different. So here 3 factorial. What is n of e? Same denomination means here 3 factorial. Because here the probability that the coins of the same denomination are consecutive. The probability that the coins of the same denomination are consecutive. Again I am reading. The probability that the coins of the same denomination are consecutive. It means you have to take 3 different units in 3 factorial ways. That is n of e. N of s is 4 5 rupee coins, 3 2 rupee coins, and 2 1 rupee coins all stacked together in a column at random. Therefore, we take it is 9 factorial by 4 factorial, 3 factorial, 2 factorial. So n of e is 3 factorial, n of s is 9 factorial by 4 factorial, 3 factorial, 2 factorial. Then P of e equals to n of e by n of s, 3 factorial by 9 factorial by 4 factorial, 3 factorial, 2 factorial, and all will be going up, and 3 factorial, 4 factorial, 3 factorial into 2 factorial whole by 9 factorial will be coming. That is 1 by, after calculation, 1 by 210. So here, what I am going to tell, this model question will be given. in probability. This model question is in connection with the concept or the idea in permutations, in grouping. As I have told you, fruits example, fruit basket example, I have told you, no, in connection with it, in connection with that notion, in permutations, this question is based on. Like this, in many ways, logically the questions will be given. Therefore, many more questions, more percentage in number of the questions in JEE Mains or JEE Advanced, they will try to give from combinatorics. Combinatorics means containing permutations and combinations, or else from probability they will give. They will give questions in connection with trigonometry, in connection with geometry, in connection with number theory, in connection with social aspects, any social aspect. So, the paper sector has a lot of freedom to make questions for the paper with these chapters. That is why they are they feel very happy to make to cook. I say to cook some questions, more number of questions on this. To cook more number of questions, the paper sector is very happy. Okay, let us stop today because it may be 50 minutes, 40 minutes, maybe more. Now, please go through the answering the questions, the types of questions by me, answered by me in my book. Please go through it. Okay, without forgetting, go through it. And next, share, subscribe, and tell all of your kith and kin and friends, so that they learn. They will also utilize this chance and all will be happy. They will learn something. Okay, thank you. Thank you. Thank you. All of you listen carefully. Playing cards. In probability. Basically, everybody must know this. The simple thing, of course. T2 cards. Here, red. Diamond and heart. Heart, diamond, heart. These are 13. Okay. Here, club, and a spade, spade, club, 13, 13. This is in color black. Observe here. Black, club 13, spade 13, red, diamond 13, heart 13. Total 52 playing cards. And these 13 will be ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, king, queen, jockey or joker. You see, these numbers one, two, three, 4, 5, 6, 7, 8, 9. 9 numbers. This is 1, 3, king, queen, joker, ace, total 13. These 13 will be in diamond, same 13 will be heart, same 13 will be club, same 13 will be spade. This color is black and diamond heart color is red. Total 52 playing cards. This you must know. The total number of outcomes when n fair coins tossed equals to 2 power n. You have to observe it. The total number of outcomes when n fair coins tossed equals to 2 power n. This is very important point. Similarly, another important point is when n fair days, total number of outcomes, when n fair days, when n fair days rolled the total number will be 6 power n. You have to understand this 6 power n. When n fair dice rolled, then total number of outcomes when n fair, not coins, n fair dice rolled 6 power n, and fair coins tossed 2 power n. This is very important. Here on this, I will give you the question number 2. First question was discussed in the previous video. Now the second question. Ten fair coins are tossed. Then probability of getting three heads. Ten fair coins are tossed, then probability of getting three heads. Here, total number of cases equals to 2 power 10. Just we are given one formula, 2 power n, that is 2 power 10, because how many 10 fair coins are tossed, then probability of getting 3 heads. This 2 power 10 is S of n. Sorry, n of s. N of s. N of s. We have to now let us find n of e. Getting 3 heads. That is, remain all tails. Remain all tails. that is total number of favorable cases of the event favorable cases of the event equals to the number of arrangement H T like this T. How many? 7 tails. Because 3 heads we want. It is equals to 10 factorial by 3 factorial into 7 factorial. This is n of E. You please try to understand here. Again I am telling. Here question is 10 fair coins are tossed. So what is the 2 to the power 10 n of S? That should be in denominator. N of E, what is n of E? He has mentioned that one, getting 3 heads. Getting 3 heads. 10 fair coins tossed, no. Suppose it may be H, 3 heads, tail, 7 tails. Total 10 coins. If just after tossing turns up, 10 coins turns up on the land, H, T, 7 tails and 3 heads like this. For this, how to write in permutations? In permutations, we write 10 objects, that is what, 10 coins, because 10 fair coins. So 10 factorial by 2 groups. What are the 2 groups? Heads and tails. What is the case we have to take? Favorable case we have to take. The favorable case we have to take 3 heads. That is why first I have written head, 3 heads and 7 tails I have written. So for that, 3 heads and 7 tails. This is one group and this is another group. 3 heads in 3 factorial, 7 tails, 7 factorial. So 10 factorial by 3 factorial by 7 factorial. If you write like this, the thing is three heads permutations, when three heads turn up permutations, while tossing 10 coins, three heads turn up permutations, we can write like this. This is the formula we have learned in permutations, that is groups. In the group, as a group, we can write the formula like this. For example, I will tell you 10 fruits are there. Some 3 fruits are apples and 7 fruits are oranges. What is the permutations of these 10 fruits? 10 factorial by 3 factorial, because they are like things. The 3, what I told, are 3 apples I told, 7 oranges I told. So in one basket, 10 fruits are there, 10 fruits, out of 10 fruits, 3 apples are there, 7 oranges are there, for example, I am telling. Then how do we arrange 10 fruits? How do we arrange 10 fruits in a row? 10 factorial by 3 factorial into 7 factorial. You can tell like this. Okay, this is grouping. This is grouping. I think this example you can understand very well. In one basket, 5 mangoes and 3 oranges and 4 apples. Total how many fruits are there in the basket? 5, 3, 8, 4, 12 fruits are there. So 12 fruits, how do we arrange 12 fruits? 12 factorial by 5 factorial into 3 factorial into 4 factorial. Remember this. Like this, we have given n of e. So, what is the probability of this? Probability of the event is favorable events. So, n of e by n of s. What is n of e? N of e is 10 factorial by 3 factorial 7 factorial whole by n of s is 2 power 10. This is, we can write this as equals to, we can write this as 10C3, 10C3, we can write like this, 10C3, 10 factorial by 3 factorial into 7 factorial. When you are given 10C3, 10 factorial by 3 factorial into, subtract, 10 minus 3 is 7, no? 7 factorial, like this. 10 factorial by 3 factorial into 7 factorial. For example, I will tell you 5C2. What is the 5C2? 5C2 equals how much? 5 factorial by 2 factorial. 5 minus 2, 3 factorial. Okay, like this. 10C3 by 2 power 10. This is the answer. For the same question, second bit, at least 5 heads. At least 5 heads. At least 5 heads. at least 5 heads. How to find at least 5 heads? At least 5 heads. At least 5 heads means 5 heads, 10 coins if you toss. All coins, suppose 10 coins have taken 10 kids and every kid has tossed it. All fallen on the ground, turning up our favorable event. Suppose we say turning up our favorable event. What is our favorable event? At least 5 heads. It means 5 heads, 6 heads, 7 heads, 8 heads, 9 heads, 10 heads, like that. So what is it? 10C, at least 5. At least 5 means 10C5 plus 10C6 plus 10C7 plus 10C8 plus 10C9 plus 10C10. What is this? At least 5 heads. Favorably, we are assuming favorably after tossing, turning up at least 5 heads. Let us suppose favorably like this. Then 10C5 plus 10C6, 10C7, 10C8, 10C9, 10C10. These are the ways. This is the selection. Okay, whole by, what is it? 2 to the power 10. 2 to the power 10. 2 to the power 10. That's all. And you will simplify, and you will simplify this one. You will simplify this one. This one you will simplify. That is the other thing. According to, even in binomial expansion also, you can find it. Here, what is that simplification? Afterwards you will learn it. But the answer is 10C5. You know 10C5? What is 10C5? 10 factorial by 5 factorial. Yeah, 10C5 means, I told once 10C5 like this. Once I told like this, 10C5. 10C5 means I told you, how I told? 5. 10 into 9 into 8 into 7 into 6. 1, 2, 3, 4, 5. Whole by 5 factorial. 5 into 4 into 3 into 2 into 1. Like this. So 5 times 10 backwards you have to write 10, 9, 8, 7, 6 like that. And 5 factorial means 5 to 1 backwards. You have to write all natural numbers. So here 5, 2, 10, 10 cancel, and 4, 2, 8 cancel, and 3, 3, 9 cancel, and what will be 3, 2, 6, 36 into 7, you will get it. Okay, like this you can calculate. But anyhow, the probability of at least 5 heads is 10C5 plus 10C6 plus so on up to 10C10 whole by 2 power 10. Okay. See this third one. In a convex hexagon, two diagonals are drawn at random. In a convex hexagon, two diagonals are drawn at random. Two diagonals are drawn at random. The probability that the diagonals intersect at an interior point. The probability that the diagonals intersect at an interior point of the hexagon is. First of all, you have to learn. First of all, you have to learn one thing here. Here, I want to tell you one thing. I have drawn like this. This is convex hexagon. Convex hexagon. More than 180, no angle will be. Total angles will be like this only. This is convex hexagon. How many sides? 1, 2, 3, 4, 5, 6 sides. How many vertices? 6 vertices only. 6 sides, 6 vertices. 1, 2, 3, 4, 5, 6 vertices. How many diagonals? From this point we can draw the diagonal like this. We can draw the diagonal like this. We can draw the diagonal like this from this point. From this point we can draw the diagonal like this. We can draw the diagonal like this. And we can draw the diagonal like this. 3, 3, 6. And from this point, we can draw the diagonal like this. And we can draw the diagonal like this. And we can draw the diagonal like this. Totally, we can draw 9 diagonals. We can draw 9 diagonals. Total diagonals, 9 diagonals. 6 sides. 6 vertices. So what is the question? In a convex hexagon, 2 diagonals are drawn at random. 2 diagonals are drawn at random. 2 diagonals are drawn at random in convex hexagon. So, how many diagonals are there? How many diagonals are there? Here, what we have to take? So, n of s, 9 diagonals will be there, and we have to select 2 diagonals. Very easy. But you have to know how many diagonals are there in the convex hexagon. Here, so 9C2 is the n of s. 9C2 means, I told you this one, here is 2, so 9 into 8 backwards you have to write 2 factors by 2 into 1. 2 factorial means up to natural numbers backwards you have to write 2 4s and 36. Next, n of e equals to 2 diagonals we at random we have taken, no? Those 2 diagonals must intersect at an interior point. So here those two diagonals intersect at an interior point. How many six C4. What is 6? I have taken six. I have taken six sides, 6 vertices, not sides. 6 vertices. 2 vertices. If I join, one diagonal will come. 2 vertices. If I join, one diagonal will come. Another 2 vertices. If I join, another diagonal will come. So I have to select 4 vertices out of 6 vertices. Out of 6 vertices, I have to select 1, 2, 3, 4 like that. 1, 2, 3, 4. This will, and this will. So here, out of out of 6 vertices, I want to take 4 vertices because 2 vertices, if I join, one diagonal will come. So those 2 diagonals joined by 4 vertices, supposing intersect at an interior point, of the hexagon, convex hexagon. So I am taking 6C4. What is 6? The number of selections of 2 diagonals which intersect at an interior point. I have taken them as the total number of selections. The total number of selections of 4 vertices is equals to 6C4. 6C4 I have taken. This is 6 into 5 into 4 into 3, because this is 4. So 4 times 4 factors I have to write backwards. Backwards I told. 6, 5, 4, 3 by 4 factorial means 4 into 3 into 2 into 1. Factorial means you have to write natural numbers up to 1. 4 into 3 into 2 into 1. So 4 cancel, 3 cancel, 2, 3, 6. So what we are getting here, that is 3 5s equals 15. What 6 is? 6C4. Our favorable thing. 6 vertices are there. 6 vertices are there. Any two vertex can give us diagonal. So 4 vertices I have taken for the 2 diagonals, which are assumed to be intersecting at an interior point. That is 6C4. 9C2 means I have selected 2 diagonals out of 9 diagonals. That is N of S. Therefore, probability of event equals to N of E by N of S. N of E by N of S equals to N of E is 15 by 36 and equals to 3 5s and 3 12s. That is 5 by 12. 5 by 12. 5 by 12. 5 by 12.